Haines. Luckily, your mom's really helping me. Yeah, it's really like untitled chapter being done. No, it was not. He's very bad. He's like,
We're on
no.
chapter 4.
We are on chapter 4.
He's very bad.
Chapter 4,
Yeah, 4-1. And some of this is going to look familiar. Real familiar. But what I think you're going to see is that some of it's going to have a little bit different twist on it. You know, the format is a little bit more formal. The numbers are a little more challenging to deal with, but it's all about solving percent problems with equations.
Oh, yeah, I remember percent.
Yeah.
Percent in my part.
You know, I think in 8th grade we went over percent problems a bunch of different ways. And I'm going to tell you, you can draw upon any of your experiences to solve these. There's lots of ways to solve percent problems. You can write equations. You can set them up as proportions. But remember, percent means out of 100, always. Realize when you're writing problems, think about it and ask yourself, you know, is the number that I'm writing or is the variable I'm writing, is that a decimal number? Is it a percent number? Is it a fraction? Keep all of that in mind. I think background, if we go from a fraction to a decimal and then to a percent, you could think of the fraction being changed into a decimal by taking numerator divided by denominator. So to get from here to here, we use division. We divide the fraction, turn it into a decimal. To get from a decimal to a percent, what do? Let's use a fraction as a half. So 1 divided by 2 equals? How about not? Not 2. 1 divided by 2 is not 2. 2 divided by 1 is 2. The 1 divided by 2 is 0.5. And 0.5 is what percent? 50. So to get from here to here, we had to multiply by how much? We multiply that by to turn it into 50. 100. Yeah, multiply by 100. And what I say is we multiply by 100%. So if we keep those things in mind, it's going to help us in solving these problems. So the lesson is using equations. Yeah, I think this word was using, but same. In the first example, they say that this is a general form of an equation that we can use. P equals Q, or P times Q is equal to R. So P is going to be the percent, Q is going to be the quantity, and then R is going to be the amount that percent is of a particular quantity. So the first example that they give us is they give us something in words, and they say 7% of what number is 91. So 7% of what number is 91. What we're supposed to do is just recognize that there are certain words that have that meaning. So what do you see in here that would be like operations or equals, symbols that we use when we write a math equation? Which are words that translate to symbols? Of? What is of? That's not divide, no. Oh, you guys know where to go, right? Okay. So I'm gonna let this thing run, otherwise I gotta start it again. So you're on your own, because I have to go.
It was a planning process.
So did you get yelled at and screamed at out there?
No.
Isn't that nice?
Did you know that if you run out of coffee creamer, ice cream, or whipped cream works pretty good?
Yeah.
Yeah.
You can use yogurt too if you don't mind the sugar, but you can use plain yogurt.
We didn't have yogurt.
You can use plain yogurt instead of mayonnaise when you're baking and cooking things.
And what?
Use yogurt, plain yogurt instead of mayonnaise when for cooking stuff. All right, so we gotta keep going. We lost 5 minutes. That wasn't bad. 6 minutes. Okay, so they say 7% of what number is 91? And we want to take that, kind of match it to this equation. That's really what we're doing. So like Trenton said, of is going to be?
7% of 100.
Of is what? Add, subtract, multiply, or divide? It's multiply. So we could initially think of this as 7% times, and then what number, what would we write? X, or a variable, is equals 91. Now we can't multiply percents. So that's why I threw that up here. So you gotta take that percent, either change it to a decimal or to a fraction, whatever you're most comfortable with. Because percent means out of 100, you could write 7/100 times x is 91. And then you've got one step, inverse operations, done, right? But 7/100 is what decimal number? 0.07 times x is 91. So that we could just do inverse operations of division. So whatever you're most comfortable with is fine with me. But no magic, no going from this to an answer. Show me something here at least for a little bit. So in this case here, how would we clear that fraction? If we wrote it as a fraction, how do we clear it? The first one. How do I get rid of that 7/100 and get x alone? Marvis? Multiply by the reciprocal. Both sides. So then it's 91 times 100 divided by 7, because the left-hand side everything cancels out. So what do you get from that? That's why you get those $140 calculators in front of you. You should have the thing go bang, 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 bang. Go. You can't go faster than me. You can't beat an old man with one of these things.
9,100.
That doesn't work. 9,100?
It's 1,003.
1,003, I get 6.37. Golly. I don't know. Maybe not, 0.07. 0.07, oh, wait, no, it's 91 divided by 0.07. You're right, 1,300. Oh, okay. This one here, if you divide by 0.07, you'll get the same thing. So x is equal to 1,300. There you go. All right. So let's put another one over here. Another way that you might see something written like this is, what percent of 160 is 38.4? And I think that when you see these statements like this, the easiest thing to do is, if you look at how it's written in words, what percent of, and then they give a number, and then they say is, and if you just look at that, put your notebook up underneath it, what percent is going to be a variable? Of, multiply, 160 is equals 38.4. I can't write on this thing sideways, I don't know. Maybe it's because I need to be on this side. It might be, okay. So could you get through this one? What would you do to come up with n? Divide by 160.
160.
Yeah. So what's 38.4 divided by 160? Two four. To keep going? Really? It just ends at 0.24. Good. Okay, now, this here, is that a percent? No, that's not percent. So what do we gotta do? What do we have to do that 0.24? Yeah, see, if we put that in here, we would have 0.24 times 160 is equal to this, but that would be the equivalent of what percent? 24%. So make sure you get your answers in the right form. You might be coming up with a decimal. I don't really know a nice and neat way of writing this any other way. This is where you just have to kind of use your intuition and ask yourself, if I'm multiplying, would that have been a percent? No, it can't be, therefore my answer won't be either. And we have to change it to a percent.
Can you put another a 0 in front of the 2, like behind the decimal? So like 2%.
So, okay, so related but not the same. If you had that, is that 2%?
Yeah.
Yes,
Okay.
because that's 2/100ths. 2 out of 100, 2%. Good question. Okay. Last one. Ian, Cassidy, Quincy, Dillon. Ate at a local restaurant. The meal cost $36.50 without a tip. And the bill states an 18% gratuity or tip will be added for parties of 4 or more people. Find the cost of the meal and the tip. So that's pretty common in restaurants. They'll say right there, if it's a party of more, not so much 4, but usually it's like 6 or more than 5 or something. And then they add on an automatic tip amount, usually about 20%. And they do that because sometimes what ends up happening is when lots of people are sitting at a table eating together and they're paying for their individual meals, they don't tip very well. And then the servers have a lot of work to do running around taking care of those types of tables, and they kind of get shorted on an appropriate tip. So here's what we've got. We got $36.50 without a tip, but it says an 18% tip is going to be added. So if you think of it this way, you have the cost of the meal plus the tip. That's going to be your total. So you have to look at those individually. So what did they say the cost is? 36.50. And then what do they say the tip is? %. But 18% of what?
36.
Yeah, 36.50. Because 18% is not a quantity; it's like a portion of. So now, if I'm going to say 18%, we've got to change that to a decimal because it's going to be of the 36.50. So how do we write 18% as a decimal or a fraction? Over 100 or 0.18. So this is going to be the total. So if we take 36.50, what's 18% of 36.50? 18%. How much is this amount? That's $6. Is that right? 0.50? 57. Okay, so then you add them together, that's 4307. Is that correct? want you to look at this one a little bit differently if you can. This right here, this 3650 gets multiplied by 1. And you still have 3650. This here is 0.18 times 3650. That's our total. So this is like 100% of the money that the bill is. Up here. And this is 18% of that much money. So together that becomes 118%. What we have here is we have this 3650 that gets multiplied by both the 1 and by the 0.18. So what we can do is say that this is 1 plus 0.18 multiplied by 3650. So we use the distributive property. Now this here we thought of as 118% of 3650. So if it's that amount, it's above and beyond the whole bill. So if you can look at this a bunch of different ways. You can go and think of it like this here, the way we wrote it initially. Or you can just say, well, if it's an 18% tip, now I know I have to pay 118% of the bill. So in that case, this 118% ends up being 1.18 times 3650. And coming soon, we're going to be taking a look at interest and things like that, and calculations that are done with that, with interest and finance. Use some of these ideas where we take 100% plus another percent and we put them together as decimal numbers. Okay, one more example. It says a dishwasher normally costs $3.20. So this is tips, which is adding on. It's sort of like tax. You know, if you add tax on, it's like adding 5% or 5.5% sales tax or something like that. That would be the same type of a problem here. But then there's also discounts. So if you discount something, you've got to take a portion or a percent off of an original price. And the example that they give for us to set up with this is a dishwasher normally costs $320, but it's on sale for 15% off. So $320, but if it's 15% off, is that going to get added or subtracted? You subtract it. So you have $320 and you're going to subtract 15%, but 15% of what? I can't read sign language. What are you taking 15% of and subtracting? Of the 320, so 15% of $320. So that's one way to look at it. And if we wrote this out, we could say, well, $320, subtract 0.15 times 320, do the arithmetic. But there might be another way to do it. And it has to do with what I wrote over here, where you just added together the percent and the original price percent, which is 100%. In here, what we have is we have 100% of 320, and we're taking away 15%. So if you think of this as being $320 and it's 100%, if we take out a slice of 15%, how much is left over? So if this whole circle represents 100% of the cost, but you take away 15%, what percent remains? It'd be 85, yeah. So this is what you're paying. You're only paying 85% of the cost. So we can think of this as 0.85 times 320, and that's what you end up paying. Now, the other way is if we looked at this, we're paying 85% of $320. So either way that you do those calculations, you're gonna come up with the same number. And that's gonna be what the new price is gonna be. Careful when you read the problem. Sometimes they say, what's the price? The other times they'll say, well, what do you save? So think about the context of the problems as you go through this. So, here's your 4-1. I guess it's not on here. Let me look at the computer.